A very good afternoon to all of you. This is Yogendra from Fast Coding School. Can you please confirm if you can hear me? Okay. Sauhardya saying Jaya Sharma, Manish Khyani, Dhrati, Sanjana, Bismita Chaudhary, Yogesh, Tapashwini. Okay, a lot of people raising hand now. Juhi Singh, Sripreet, Ravi, Devi, Rahul, Shivani, Keshav, Mala, Vishal, Swati, Sonu. Okay, a lot of people raising hand and a couple of them responding back in the chat window as well. Thank you guys. So let's start for today. And guys, this is a day 4, right? This is the day 4 today. And if I say day 4, this is basically the second last day as well, right? So this is the second last day of our program. We would be completing our program tomorrow evening. And for today, again, guys, if I quickly, revise what we have done so far in last couple of days, starting from Monday, I would request every one of you that can you please quickly share your learnings with us within, in the chat window, that what you have learned so far starting from the day 0, that was the start of the program on Monday, to the Thursday, that was yesterday, guys, right? Today, because we have a Friday today. So I would like everyone you to give me a message on the chat window that what has been your learning. It may not be the technical learning. It may be a non-technical learning as well. Maybe your problem-solving approach. Maybe the perception of looking at the problem. Maybe something else, right? So please do share your learnings so that after that we'll move to the today's agenda. So now a lot of people responding to me. The MATLAB was there, Matplotlib was there, train-split was there, Pandas was there. Use of libraries like Matplotlib, NumPy, Pandas, linear regression, multiple regression was there. Data pre-processing, Uddeshya saying data pre-processing there. Machine learning. Vishal is saying that I like your teaching skills. Thank you, Vishal. Soumya Trivedi saying Python libraries, linear regression, logistic regression, what data science is, what the AML is, right? Swati Lohia saying labels and features and iLock and lock. Mala Datta from Assam is saying my biggest takeaway is increased confidence in coding in Python with respect to machine learning. Swati Lohia saying linear regression. Vatla Lakshmi saying, I learned actually what AML and data analytics is. Keshav Goswami saying use of different libraries, Matplotlib, Pandas, NumPy, and also learned some algorithms on that part. Manisha Das saying labels and features and label stream and labels tests and linear regression. Devi saying concepts of machine learning, Kavita saying one-hot encoding, Jaya Sharma saying the concepts are related to AML, AI, and data analytics, Viswajit Tripathi saying NumPy, Pandas, Matplotlib, various definitions, one-hot encoding, Shubhpreet Kaur, again saying AML definitions, data analytics, and a lot more, many things. Ravi Mishra has a very detailed response and almost covering everything that we have covered so far. Juhi saying learn Pandas and NumPy, a lot of things. Okay. Devi saying very useful session, sir. We learned a lot of things. Okay. Yeah. Vishal, Vishal Dongade. I think I may be wrong in pronouncing the name. Sir, can I join the paid machine learning internship? Okay, he has a different question to us. Okay. Hmm. Ninja Singh, she's from Delhi, I hope. Ninja Singh, Matplotlib, Pandas, NumPy, linear regression, prediction, the difference between ML, deep learning, and also has a say, sir, you talked very well. I'm really enjoying this session, and the most important thing that you are teaching all practically. I really like it. Okay, thank you, Ninja. So. Lipika Devangan has a say, I learned each technical things you taught, but mostly your constant focus and patience consistently throughout the session. Akshat saying you are the best teacher. Thank you, Akshat. It may not be true actually. Venkatesh saying, "Sir, I'm late. I joined now." Don't worry, Venkatesh. We just covering what we have done so far in the last 4 days, and there was nothing new started yet. And now you can join, and we are starting now. So uh, for me, Professor David Malan is the best teacher. Professor David Malan, if you Google, he's the best teacher actually. Okay. So guys, now I think we can start now. Before I start for today, guys, right? Let me give you a couple of announcements, guys, right? Two announcements I have. Your design of the certificates is ready with us now. So the certificate that you will get after completion of this course and registering for it, guys, this is the design of the certificate. And I think it covers almost everything. And this is one of the best design we have so far. We have got a very good feedback from the previous batches as well about this design. So this is the design, guys. And for registering for the a certificate, I'm going to share a link with you now. So this is the link. You can go and register yourself for the certificate. The certificate would be issued, right? The certificate would be issued to you on Monday, right? And obviously, as I said in the beginning of the program, the certificate is paid. You have to pay 300 rupees for the certificate. And I think it's worth to pay for the certificate, because the kind of learning you have gone through or kind of the confidence you have gone through in machine learning now, I think it's worth to pay around that. I can recommend around that. And this is the link, guys, I have shared with everyone. This is the link where you can go and pay using Paytm or Google Pay or UPI. You can do anything. So Sunday, I think Sunday evening is the the time you can register by, and after that registrations would be closed, and Monday you will be getting your certificates. That is the announcement I was talking about regarding the certificates, guys. So now let's start for today. So guys, are you excited about today's learning? Because again, we have many things to learn, and today we are on the classification journey. So far we were on the regression, but now we are moving towards classification. And now again, there would be a lot of things to discuss and to share with you. So let's start with, guys. Sahil, keep this question at the last. I'll answer that part. Okay. Guys, if I quickly again create a mind map for you, right? Quickly create a mind map for you. If I say what the AML is, then machine learning, right, has two subsections: supervised machine learning, and the other one is unsupervised machine learning. And if you remember from yesterday's discussion, I defined the unsupervised machine learning as well to you. In case of supervised machine learning, the data set you deal with, to solve a problem, it has both. It has features and it has a label, right? And in case of unsupervised machine learning, you only have access to the features, right? And sometimes it may be a possibility that data set contains label as well, but the problem statement is like this, that you have to deal it under unsupervised machine learning. In that case, you are not going to use the label even if it is given to you, right? Even if it is given in the data set, but the problem statement is like this, that it has to be solved through an unsupervised machine learning approach. Obviously, you're not going to include the labels, even though they are given. You have to exclude them, right? And just keeping the features in the data frame, you are going to solve that problem. And now, if you say under the supervised machine learning, you again have two subtypes here. The regression was there, classification is there, and we have spent a good amount of time. Last 2 days we were only talking about the regression, because along with the regression learning, I think a lot of new concepts were also introduced to you, and those new concepts now can be very well used in other algorithms as well, right? So today, some of the activities that we have, right, some of the activities we have will include the past learning or the last 2 days learnings as well. So now things should be moving a little fast rather than the last 2 days. And now in the regression part, the algorithm that we have really covered is linear regression, right? There are other algorithms as well, but the focus was on the linear regression. Now on the classification part, I'm planning to cover 4 algorithms for you, right? So obviously, I will discuss the kind of concepts around these algorithms and use them in problem solving. The algorithm that we are going to discuss is the logistic regression, guys. The algorithm that we are going to discuss is KNN, K nearest neighbors. K is a number actually, right? Nearest neighbors. Then SVM, support vector machines, and naive weights. So these are the 4. There are a couple of more algorithms as well. What, the current focus would be on these 4 algorithms. And similarly, in case of unsupervised machine learning as well, yesterday I told you that clustering is one subtype here, and the association is one more type here. And in clustering, basically you divide the data into multiple groups using features only. And the best or the most popular algo that comes here is k-means, but there are others as well. DB scan is one more algorithm here. Hierarchical clustering is one more algorithm there, but that is the most used algo. And then similarly in the association part, you have a priori as the algorithm, right? Obviously, this is not the focus of this entire program. Our focus remains on this supervised ML only. And regression part is closed now, right? Regression part is closed now. And we are now on the classification part, guys. So today, the second last day and the last day, we would be spending our discussion on classification now, guys. So is that clear with everyone, that today and tomorrow we are going to focus our discussions on the classification, and still we are in the supervised machine learning, guys. Still we are in the supervised machine learning. Is everybody clear about it? Please respond. Okay, okay, now I can see people responding. Okay. Now, guys, as I told you in the classification, that when you are in the classification of supervised machine learning, you're solving the classification problems, what you predict a category or a class, right? You predict a category or a class, that is, let's say, win or loss, right? Delay or on time, placed or not placed, hit or flop, right? A kind of, let's say, cat and dog, let's say you have an image and you want to predict that, who is in the image, right? So it's a cat or it's a dog. So you are trying to predict a category or a class. That is a classification problem, right? And in the classification problem to solve, I'm going to use two algorithms today, one by one. The first algorithm that I will discuss with you, I will give you a brief idea around that, is the logistic regression. Don't go on the name, it is for classification, although name looks like that, right? That it is a regression, but it's a classification problem. And the algorithm that, second algorithm that we are going to discuss is KNN, okay? And now see this, what the problem we have for today to solve. Okay, we would be using a logistic regression to solve that problem. And let me tell you if you understand it well or not. So I'm just going to explain the problem to you first, and then, we'll start, we'll write the code to solve it. Guys, I have a CSV file, heart disease.csv. Okay, what the file is all about. Basically, this data belongs to a medical fraternity. This data has been collected from a website called UCI repository, right? So this is the website where you can also get your data for, for practice. The repository that I'm talking about is UCI repository. UCI repository. Right. So if you search on the Google, it's a very popular site. There are a lot of data sets available. Data sets available for regression problems, data sets available for classification problems, data sets available for, clustering problems and so on, or even for association. There is one more site as well, which is called as Kaggle, right? So Kaggle is also one of the sites. Along with the data set, you also get, solution to some of the problems there, guys. So Kaggle is a very, very, popular site amongst data scientists, and now it has been acquired by Google, right? I think the first president of this Kaggle society was Jeremy Gordon. Is a very, fantastic person in the field of machine learning, and Jeremy Gordon is a very, very, so you can listen to some of his TED talks. Amazing personality, so TED talks you can listen, Jeremy Gordon. So now it has been acquired by Google. And what the problem we have right now, so let's look at the data first. Guys, the name of the CSV file is heartdisease.csv. What does it contain? Let's see this. So what does it contain? Guys, this is actually, Jeremy Gordon. Jeremy Gordon, that was the name. Okay. So, he's a very popular face, even on the internet, I think. Let me give you, if that is there. Mm. Jeremy Gordon. I think it should be Jeremy Gordon. जहाँ तक मुझे ध्यान है, probably. Let's see if that is okay. Jeremy Gordon. Okay, that's name here, guys. So must have a name there. I think you can search more on that. This is talking about some player, but he's a data scientist actually. So guys, the problem we have is it is about the heart diseases, and what the problem is that for every patient that got admitted into some hospital, the hospital department collected some of the vitals for each patient, maybe his blood pressure, maybe his, sugar levels, maybe his, kind of other things like hemoglobin, and kind of those details were collected, and all of those details have been named as V1, V2, V3, V4, V5, V6, V7, and V8. That means for each patient they collected 8 samples, right? Exact names are not given, just V1, V2, V3 and are given only. And after that, up to V9 it was there, and after that there is a one more column added against each patient record, and this number is either 2 or either 1. Can you see, guys? The last column has either 2, 2, then 1, then 2, 2, then 1, then 2, 1, 2, 1, right? So basically, right, this is saying that whether that patient was a heart patient or not, heart disease usko tha ya nahi tha, right? So that was the kind of data we have, right? And there you see that we have given a label here actually, right? We have given a label to every patient, 1 or 2, right? So let's say maybe you assume that 1 is that he was or she was a heart patient, and 2 says that he was not a heart patient, right, guys? So we have only 2 categories, only 2 classes, right, in the label. Either it is 1 or either it is 2. 1 indicates that he or she has a heart disease, or 2 indicates that no heart disease, right? So that is the case, guys. And now given this data, right, given this data, guys, now there is a new patient coming up in the hospital, and we collect these 9 samples, right? And based on these 9 samples, now we want to make a prediction whether he or she will have a heart disease or not. So guys, what the problem we have, that we have to predict, right, that guy that has been admitted or that has been tested or samples have been collected, right, will he have a disease or not? So that means we have to predict either 1 or either 2. So guys, what do you say? Is it a regression problem or it's a classification problem? What do you say? What is your understanding around this? So Paridhi says it's a classification. Sahil says it's a classification problem. Okay, so a lot of people are saying it's a classification problem, right? Obviously, it is a classification problem here, right? Because we have to predict a class. 1 or 2 are numbers, obviously, but the number represents some class, right? 1 represents that heart disease was there, and 2 represents that no heart disease. So in a category and a class, kind of a win or loss, right? Kind of a heart patient or not a heart patient. So that is the classification. Placement होगा या नहीं होगा, it's a classification problem. लेकिन salary क्या होगी monthly, it's a regression problem, right? So that is there. नेताजी चुनाव जीतेंगे हारेंगे, classification problem. कितने वोटों से जीतेंगे हारेंगे, regression problem, that is there, right? So it is a classification problem, guys. Juhi, right? So now how to deal with this problem, how to solve this problem, right? So obviously it is a supervised machine learning problem, and the kind of template we have created in the last 2 days, that how you can load the data, how you can extract the features and label separately, how you can train test a split, how you can go for the algorithm and apply it, how you create the object, how you fit the model, how you get the prediction. That is going to happen here as well, right? So let me first deal with the pre-processing part, guys. Let me deal with the a pre-processing part, guys. So v1, v2, v3, v4, v5, v6, v7, v8, they all are features up to v9, and the last column is a label. So guys, do you agree with me that v1 from v1 to v9, everything is a feature, and the last column is a label, class is a label here, right? So how to deal with this? So let's write the code for it. Okay, because we have already written a similar code, so we can take advantage of that. Can we copy that code from the yesterday's discussion? Yes, we can copy this code. So guys, we have this. See this, see this, see this. Okay. Okay, I'm going to copy everything, and that what is required we'll keep it, and what is not required we'll just remove it from there. So guys, see this. A very well-known fact that now we need to import these libraries. So okay, done. We are done with importing the libraries. We imported pandas, we imported numpy, we imported matplotlib. And now, guys, we are going to read the data first, right? So we need to, load the data in our data frame, and the name of the file here is not salary classification. This is the previous code actually. So we have to change it. So the first change that we are making here is this heart diseases, right? So that is the CSV file which contains the data for us in today's problem statement. So now this is the data set we have. Oh, what it says, guys? Either my directory are different, or what is that? So just a minute. Can we check what is the current directory we have? Import OS. I think we can import OS and os.get cwd. Get current working directory. Okay, we are on the right directory. Okay, then what's wrong with that? So okay, it's not diseases, it's disease. Okay. So anyway, guys, thank you for pointing out. So now, guys, we have the data frame with us, and now you can see it has in total 462 records and 10 columns we have, right? So if you double click on this, this is v1, this is v2, v3, v4, v5, and v6. Okay. Now we have to collect the features and labels from it. And if you remember, guys, our last column is actually the label, right? Our last column. And the last column can also be indicated as -1 in terms of indexing. So here, that's what we are doing here, guys. Data set we have, we are applying the iloc method. We want to select all the rows, comma. After the comma, we are just saying -1. Just saying -1 means I'm only interested in the last column, nothing else, right? And dot values gives you the actual data, and there you get the labels. So here you get the labels, guys. So labels are now with us. So now you can see, guys, 2, 2, 2, 1, 1, 1, 1, 1, kind of that, right? So everything is there now in the labels. Okay, now we need to extract the features from our data, but first we need, need to see that from where, from what index and then up to what index we have to go. So guys, this is index 0, this is 1, this is 2, this is 3, this is 4, then 5, 6, 7, and guys, 8. So 0 से लेकर के index 8 तक, we have all the features. So how we can make the features for us? So data set, that is our data frame. We are applying the alloc method. We are going to select every row, but we need to make a change here, right? So from 0, and then we have to go up to 9. Why 9? Because 9 is excluded, right? So it will start from 0, take 1, take 2, take 3, take 4, take 5, take 6, 7, 8 only, not 9. So 9 is excluded, guys. So now we have the features with us as well. So we have the features as well, guys. So now features are ready with us. Okay. So this is the way we, separated out the, uh, features and labels from our data frame. And now see, we want to check the data type for every column. See this, guys. The V1 column is int 64, V2 is float 64, float, 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 and float. Guys, do you see is there any column which has a type object? Guys, do you see, is there any column which has a type object? There is no column which has a type object, guys, right? That means there is no categorical data in our data frame, guys, right? There is no categorical data in our data frame. Guys, do you agree with this? Please respond. Okay, right? And as we do not have any categorical data in our data frame as of now in our features, we do not need any kind of one hot encoding, right? One hot encoding kab chahiye? You only need one hot encoding in case when your data has a categorical column. But as of now, we don't have anything like that. So we are not going to, go for one hot encoding or something like that. That was just, done yesterday, guys. So I'm going to remove everything, right? So I'm going to remove this column transformer code, one hot encoder code, and this code, and dropping the one column as well. So I'm going to remove everything from this set because everything is already numeric. So I don't need any, a code related to one hot encoding. So that part was removed now. Now, guys, once your data is in numeric format, features and labels have been separated out. What you need to do now? Now you need to go for train test split, guys, if you remember, guys, right? You need to go for a train test split. So, guys, I'm just going to remove this part. It is duplicated here. So from sklearn.model selection, we are going to import the train test split that was done yesterday. And now while calling the train test split, you need to pass on the features and the labels that you have from the data, keeping the test size to 20% and random state to 0. It will split your features into features train and features test. It will split your labels into labels train and labels test. So we have the splitting, guys, now. So we have the splitting now, right? Okay. And now, let's look at features to train, guys. So we have features train, we have features test. By combining these, it will make features. We have the labels train and labels test, guys. And if you remember from yesterday's, guys, while fitting the data in any algorithm, what we use features train and labels train, right? And to test the model, what data we use for prediction? We use prediction features test for prediction, and we compare those predicted values with the labels test. That was very well discussed yesterday. But now let's have a little closer look on the feature stream, guys. Let's have a look on this data. That is, a little something new is coming up for you. A new learning will be here, guys. See this. Guys, can you see that the first column has the values in 3 digits? The second column has the values in, 1 digit, 1 digit here, 2 digit here, 1 digit here, 2 digit data here, 2 digit here, and so on. So that's here, guys. So some of the columns have a 2-digit data, some of the columns has a single-digit data, and some of the columns has a 3-digit data as well. Okay. And now I'm going to introduce one more concept. That concept is known as feature scaling. What we call that concept, guys? Feature scaling. What is that? I'm going to discuss now, and why it is important for us in terms of data pre-processing. So let's come to our sketch now. See this, guys. See, there is a problem, guys, for us. Let's say, guys, you are in a classroom. Everybody is in a classroom now. And there is a professor A who teaches, let's say, data structure to you, right? And there is a professor B who teaches, let's say, machine learning for you, for example, right? And today, somehow professor is not interested, or not interested to teach. So he plans to take a surprise test for you guys, right? And let's say that test is conducted on the scale of 100. So questions he gives, the maximum marks are 100. You know, that is there. And everybody scores there. So somebody scores 20 marks, somebody scores 40 marks, somebody scores 60 marks, somebody scores 55, somebody scores 15, somebody scores 75, or something like that. So these are the couple of scores, right, amongst the students. Okay. Professor B is also not in a very good mood today, and he also takes a surprise test for you. But this time he keeps the maximum marks to 10 only. Okay. So he gives some couple of questions to you to answer, and then you write those answers on the sheet. And now he evaluates, and then you score, let's say the student scores 5 here, somebody scoring 2 here, somebody scoring 6 here, somebody 3, somebody 7, someone 5, or someone 8. So that is the case, guys. Okay. And now, just to showcase your progress, your report, your status to the principal, right? They need to present the collective score. They need to present the collective score of every student, that what has been the overall performance in both of these subjects, DSA and machine learning. Then how they are going to calculate your performance. Maybe one approach can be, right? The one approach can be like this, guys, that maybe the professor V for machine learning, he scales up the scores, right? So rather than using the scale of 10, now he converts all of your scores to the scale of 100. So that will help in easily summing up the scores, because this is also on the 100, and now by just converting these values on the scale of 100, right? So every score would be in the scale of 100 now, right? So this will become 50, this will become 20, this will become 60, that 30, that 70, that 50, and that 80. And now, because both of the scores are on the same scale, it's very easy to sum, giving a sum and finding the overall performance, that this is 70%, this is that, and that. The second approach can be, right, that rather than having a 100 scale here, so we keep a scale of 10 here, but we scale down here, right? And how we scale down? Now we scale down to 10 only. So now the score would be 2 here, 4 here, 6 here, 5.5 here, 1.5 here, 7.5 here, 9 here, guys, right? So now in this case as well, the score is on the 10, right? So guys, right, if you see that to get the overall scale, or to get the overall performance in every subject, we were keeping them on the same scale. We were keeping them on the same scale, right? This kind of an act, right? This kind of act is basically called as feature scaling. इसको हम लोग बोलते हैं feature scaling, right? Why it is important? Why this is important in case of machine learning as well, right? So see this, guys. Here, the original score was in 2-digit. Original score here was in single digit, right? Similarly, in this case as well, guys, couple of values, couple of columns are 3-digit, someone is single digit, someone in 2-digit. Basically, every machine learning algorithm that we use works on the magnitude of the data. कोई भी एल्गोरिथम डेटा के मैग्नीट्यूड पे काम करती है, ना कि उसके यूनिट पे. इट डजंट केयर दैट इट इज इन kilometers, or it is in meters, or it is in centimeters, or it is in kilogram, or it is in a gram, or it is in milligram, or whatever. They don't care about the unit. They only care about the values that they see here, right? And now what may happen during the process, that the values which are in higher range may be given more priorities. That means if this column has a 3-digit data, this column may be more important than the other columns while making the prediction, right? While making the prediction, guys, right? And just to keep every column, right, to keep every column data on equal priority, what we need to do, we need to have a same scale for every column. We have to have a same scale for every column. So what we need to do, guys, we need to convert all of these column values to same scale. And that act is called as feature scaling in machine learning. Guys, do you copy this? What the feature scaling is? So Krishna Sharma, Tapashvika, Samas Desi, Vismita, Naman Chaturvedi, Vivek, Saundarya, Sahardya, okay, saying this is okay. And now the concept comes that how to perform the feature scaling here, actually, right? Ab sawal ye aata hai, how to perform the feature scaling. So feature scaling is pretty easy. See this, guys. Now, so guys, how to perform feature scaling? Let's understand that part. Now it is a mathematical operation. Okay, how to do that? Let's say this is your data. There are 2 columns, right? And some values are given here, like 2, 3, 5, 10, 12, 6. Some values are given here, 100, 250, 750, 120, kind of that, right? 100. So these are the 2 columns here, guys. This is column 1, this is column 2. Now here you can easily see this is a single digit data, and up to a 2-digit only, and this is 3-digit data. And now how to perform the feature scaling, how to bring them on the same scale. And for that purpose, what we do, we apply a mathematical formula. And what is that formula? That from every value that we see in the column, let's say that value is X, we minus out the average of that column, and we divide it by a standard deviation, guys. The standard deviation is a mathematical term which says कि a range में कितना variation हो रहा है, how the values are varying, right, around the mean. Average से कितना आगे या पीछे values हैं, उसी को standard deviation कहते हैं, right? So this is the way, guys. So what happens here, first we go to this column, we find out the mean. So let's say this mean is M1 and the standard deviation is STD1. And similarly, we go to this column. So let's say the median is, the mean value is M2 and the standard deviation is this. And now what happens, guys, while applying the feature scaling on this column, we do a calculation for every value, 2 minus M1 divided by STD1. So that would be the value. Again, 3 minus M1 divided by standard deviation, 1. All right, 5 minus F1 divided by standard deviation, 1. So on. This is the case. And similarly for this column C2, guys, what will happen? We will take every value. Let's say the first value is 100. So 100 minus M2 divided by standard deviation, 2. 250 minus M2 divided by standard deviation, 2. This way, what will happen? Some of your values which are lower than the average, they will become negative. And the sum of the values which are greater than the average, they will become positive, right? So now let's apply this concept, right? Now let's apply this concept and, perform the scaling here guys. So see this guys, I'm going to apply the feature scaling. How to apply the feature scaling? I need to have a method for it. The name of the method that is there in scikit-learn is called as a standard scaler. So how to get that method guys? From, okay, sklearn dot pre-processing guys. It's a part of the pre-processing activity, right? So pre-processing, and then what we are importing guys is standard scaler, right? So standard scaler. So this is the guys standard scale. So guys, is the method was clear to you that how we were doing the a feature scaling, that for every column we were calculating the mean and standard deviation, for this column as well, right? And we can we can use numpy for that, right? We can use numpy to calculate the standard deviation. We can calculate, right, to we can calculate the mean using numpy. That is there guys. Okay guys, one more point here. uh, I did not discuss the feature scaling yesterday. Why? Because I don't want to put everything into a plate where you can't handle it, right? You can't eat it. Although it was required yesterday as well, if there is a if there is a kind of a variation into the range, right? किसी कॉलम में हाई रेंज में वैल्यूज हैं, किसी कॉलम में लोअर रेंज में वैल्यू हैं, ये कल भी रिक्वायर्ड था, बट हम एक एक करके चीजें सीख रहे हैं. So every day we are learning new thing, right? And they would be applied everywhere. It is not only that they will be applied in the classification problem only, they would be applied in the regression as well. But I'm going to introduce the standard scaling today only. And now guys, once these average and standard deviations are calculated, we can use them to perform the calculation that x minus mean divided by standard deviation. So obviously from this formula now you can easily understand that if your x is lower than the mean, what would be the output? It would be negative. And if your x is greater than mean, so output would be positive here, right? So that is the case now guys. So I'm going to import. So I have imported it guys, right? And now if you want to use this standard scaler, first you need to create an object of this class. So how to create an object of this class? So let's copy this method name here guys, and we are going to create call the constructor, and let's say the object name here is sc. So this is how we create the object of this, right? ये हमने इसका object create कर लिया guys. And now we need to apply this scalar on our data. Okay, so how to apply the data is in features train guys. The data is in features train and features test. दोनों में है data. So first we need to apply the standard scaling on the features train. So how to apply that guys? SC, and then we are calling a method called fit transform. And in the fit transform, we need to pass on the data feature stream. So we pass on the data guys feature stream, and we will again, overwrite the data in the feature stream. So guys, when I run it, now see this, what happens. Feature stream. Can you see this guys? Feature stream. Can you see guys now in every column, right? In every column, some of the values has become negative and some of the values have become positive, right? And now you can see the range is equal now. Now they are on the same range, right? And there is one more particular, stuff that you should know guys, that when you apply a standard scaler, after applying the standard scaling, the mean value of that column becomes 0 and the standard deviation becomes 1. Guys, I'm just saying after you apply the, that, right? After you apply the apply the standard scaling, then the average of that column will become 0, because अब तुम देख सकते हो कुछ values negative हैं, कुछ values positive हैं, तो obviously जब average निकालेंगे तो that should be close to 0, और standard deviation उसका 1 है, क्योंकि कोई भी value एक से ज़्यादा वहाँ पे 1 से ज़्यादा या कम नहीं दिख रही है. So that is in the range of that only, right? So guys, Do you copy this part that now we have successfully done the feature scaling on our features trained data? Guys, do you copy it? Right? Okay, but our act is not done yet. हमारा काम अभी खत्म नहीं हुआ है. We have the data, right? We have the data where we see features test is still there. Feature test पे अभी हमने scaling apply नहीं की है. We have to apply the feature scaling on this part as well, because दोनों ही features है ना. ये भी तो feature है और ये भी feature है, बस हमने उसको split कर दिया था. इसीलिए अब features test पे भी हमें apply करना पड़ेगा, right? So Lipika ma'am, because some of the values will go into the negative zone and some of the values will go into the positive zone, and if that data was a normally distributed kind of a data, average would be 0, right? So now, guys, I need to transform my test data as well, right? So we need to transform my test data. तो test data को कैसे apply करेंगे? Similarly, काम वही रहेगा. इस बार हम लोग SC, which is our standard scaler, we are going to use transform method only. Guys, कल आपको बताया था मैंने कि हमने जब कॉलम ट्रांसफॉर्मर पहली बार अप्लाई किया था, हमने फिट ट्रांसफॉर्म मेथड लगाया था, लेकिन बाद में जब किसी पर्टिकुलर रिकॉर्ड के लिए हमने प्रेडिक्शन मांगा तो सिर्फ ट्रांसफॉर्म अप्लाई किया, राइट? सो सिमिलर थिंग विल हैपन हियर. वी हैव अप्लाइड द फिट ट्रांसफॉर्म मेथड ऑलरेडी, and during the fit process it identified that what is the mean and what is the standard deviation. Now that mean and standard deviation can be directly used, right? Can be directly used here. So we can directly apply the transform. Fit is not required here, and we need features test data here. So features test has been there and features test is here, guys. So see this, guys. Our features test data has also been transformed. Now it is also scaled. So can you see this, guys, right? So that is the part, guys, right? So that is the part. Now, guys, if you understand this well, this is very important, guys. Feature scaling is very important, right? Now, one more thing, guys. Guys, do you agree with me that feature scaling can be applied before train test split as well, right? The feature scaling can be applied for train test split as well. If we apply the before train test split, we don't have to do it twice. अभी हमने 2 बार किया इसको, right? We did it for feature train and we did it for feature test. But if you want to apply before the train test split, you can very well do it in just one statement. You can do that, guys, because everything would be in the features and you can apply the feature scaling there, right? So guys, do you agree with this? Okay. So guys, we are done with it now. We are done it with now. Okay, now we need to apply a different algorithm, guys, here. So हमें इस linear regression की ज़रूरत नहीं है, right? अब हमें classification perform करना, because we need to perform classification, guys, right? So what algorithm we are using now, right? Now, so Tejashwini, it was simple, like, if you see, we are just creating an object of this class, and now you just apply fit transform for feature train data and transform for test data. That's it. Fit transform for training data and transform for test data, right? So that is there. Now, guys, listen. Now what we are going to do, we are going to do a classification, and for classification, the algorithm that we are going to apply is logistic regression. It is logistic regression. Okay. What is the working of the logistic regression? It is a classification algorithm, guys. Basically, when we apply logistic regression, it gives us a probability. ये हमें probability देता है. It will give us the probability of both of the classes. Guys, it will give us a probability for both of the classes. We have only two classes, guys, one or two, right? One heart disease nahi hai, two heart disease hai, right? It will give us a probability that this, I'm confident the probability of having, the classes one, let's say 70%, right? And, probability of, a class as two is, let's say 30%, right? So because ye probability zyada hai, this probability is higher than this probability, our final prediction will go for this class, guys. In case, let's say prediction is like this is, a 35% only, and this is 65% only. In that case, guys, right, what will happen? We will predict our category or class as a 2. So logistic regression is a probability based algorithm, guys. Logistic regression, right, is a probability based algorithm, right? And now we are going to calculate the probability for each class. हम हर class का एक probability निकालेंगे. And once that probability is known to us, जिसका भी high probability होगा, that would be our prediction. So how to do that, guys, in the code? Let's understand that part now. So we need to first, right? We need to first get the logistic regression class in our code. So how to do that, guys? So from sklearn dot a linear model. अभी हम लोग linear model में ही हैं. So we are in the linear model right now, guys, right? So this is, guys, there, and import which one? Logistic regression. So logistic regression, guys. So ये हमारा class, we have got it, guys. Logistic regression has been there now with us. And now how to use this, guys, in the logistic regression हम लोग कैसे करते हैं? We need to create an object. So first हमें अपना model create करना पड़ेगा. That model would be empty. So let's create, let's call this, a constructor this. And this time we name it as classifier. हमने object का नाम क्या दे दिया, guys? The classifier. So classifier is this. So the classifier has been created now. And now we need to fit the data, guys, right? Data to fit करना पड़ेगा. So how to fit the data? That is there. So regressor.fit की जगह हमें क्या call करना चाहिए? Classifier dot fit. So guys, feature strain and label strain has been given to it, guys. See this. Okay. And now we need to perform the prediction, guys. Now we need to, perform the prediction. And to predict, we already have the data. Test data is with us, guys. So test data is there. See this, guys, right? So a features test we are going to pass on. And let's say whatever comes into the prediction, we store them in a variable. Let's say I'm going to use the variable name as label spread, guys. So I'm going to change this classifier. It has to be classifier. So classifier.predict, and a test data is given to it. We have already fitted the model now, and see this, guys. And now remember, guys, the variable holds the, predicted values for us. So can we print it, guys? Label spread, that what are the predictions given? See this, guys, predictions have been given here, 2, 1, 1, 1, 2. So these are the predicted values, right? So let's, copy this data here for our comparison, because we want to compare these values with the actual data. Where the actual data is, can you guys, someone let me know कि ये तो हमें prediction में मिला है, हमें ये किसके साथ compare करना पड़ेगा to see whether the score of our model is good or bad? हम किसके साथ compare करते थे, guys? Can you understand, guys? Yes, now I'm getting responses from a lot of people. Labels test, right? If you remember, guys, what we used to do, we used to use feature strain and label strain to fit the model, and use features test to perform the prediction and compare the results predictions with the labels test, right? So I need to get the labels test as well, guys. So let me see labels test. And now see this, guys. For a first case, what was predicted by algorithm 2, or actual में भी क्या है? 2 है. What was predicted for the second patient? 1. Actual में भी क्या है? 1. What we predicted for third patient, guys? 1. लेकिन actual में क्या है? 2 है. what we predicted about fourth guys actually maybe a 2 hai. So now can you see guys, we have only 4 choices. Guys, do you agree with this? Guys, are you okay with this comparison, that these are the predicted values, right? And these are the actual values guys. ये तो हमने predict की हैं classes, and these are the actual classes. Guys, do you copy it? Please confirm करिए मुझे, because I'm going to tell a very interesting story right now for you. Right? And now see this. Now see this, guys. A very interesting part coming up, which was not in the regression yet. See this. So कुछ sample हम यहाँ पे लिख लेते हैं. The sample would be like this. कि ये मेरा predicted है और ये मेरा actual है. Right? Predicted is like this. Let's say my predictions are like this: 2, 1, 1, 2, 1, kind of that. See this, guys, right? And यहाँ पे let's say actual is like 2, actual is also 1, but actual for this case is 2, actual for this case is 1, and actual for this case is like let's say 1. So guys, देखें यहाँ पे मैंने 2 predict किया, actual में भी 2 था, correct match. मैंने predict 1 किया, actual में भी 1 था, correct match. That means my prediction was good, my prediction was accurate. Here I predicted 1, but actually it was 2. I got a wrong prediction here, guys, right? I predicted 2, but actually it was 1. Again, a mismatch. That is a wrong prediction, guys, right? See this, guys. I predicted 1, and actually it is 1. That means it is also a correct. So out of 5 predictions, 3 are correct and 2 are incorrect, right? So guys, if you see, we have a 4 combinations actually here. We have a 4 combinations here, guys. Right? What are the 4 combinations? Let's say, मैं यहाँ पे predict कर रहा हूँ 1 or 2, और actual में 1 or 2 इधर है. So this is the actual axis, and this is the predicted axis, guys. Now see this, guys. मैंने भी predict 1 किया, and actual में भी it was 1. I predicted 1 and actually it was 1. How many cases we have? This is the 1 case here, and this is the 1 case here. That means 2 cases out of 5. Guys, can you see now? I predicted 1 and actually it was 1, right? That was a match. See this, guys. So this is the case and this is the case we have, right? So that's here, guys. Okay. And then, guys, I predicted 2 and actually it was 2 as well, right? So I predicted 2 and actually it was 2. That is the case. Any other case can you see, guys? Do you see any match? No, we don't see. So I predicted 2 and actually it was 2. That was only 1 here. So 2 and 2. Okay, what about others, guys? I predicted 2, but actually it was 1. Is there any case around that? Yes, I predicted 2, but actually it was 1, right? So that is the only 1 case I can see, guys. So here it is 1. And I predicted 1, but actually it was 2. Is there any case around that? Yes, that is the case. So I predicted 1, but actually it was 2. So how many cases like that? Only 1 case is there. So that is the kind of a performance matrix, guys. This is a kind of a performance matrix where we can closely, look at the values, that how many matches we got. So this was the match. I predicted 1, actually it was 1. This was the match also, guys. I predicted 2, actually it was 2, right? So these are the correct predictions, but these are the incorrect predictions for us. This kind of representation is called as confusion matrix, guys. This kind of representation is called as confusion matrix. Guys, is that clear with everyone? And this happens only in case of classification. ये regression में नहीं होता है. This happens only in case of classification. Right? So, can we create our own confusion matrix? क्या हम भी अपना confusion matrix बना सकते हैं? Can we get it, guys? Yes, we can do that. So let's get a confusion matrix for our case as well, guys. So how to do that, guys? Can we create our confusion matrix? Yes. So first I need to get a confusion matrix from scikit-learn. So from ask a learn.metrics, import confusion matrix, guys. Okay, confusion matrix. ये मेरा confusion matrix आया. So this is the case, guys. Vansi, are you getting it? Is that clear? So that's the confusion matrix. I have got it. And now can we print the confusion matrix for our case as well, right? वो तो मैंने sample दिखाया था sketch पे. Can we use our own confusion matrix? Okay, I can get it, guys. So I'm using this method confusion matrix here, and see this. What I need to pass on, guys, for comparison, because you know how we are calculating the confusion matrix by comparing this set of values with these set of values, right? We are making a comparison out of this. So I need to pass on the actual data first. So labels test first, guys, and the label spread, guys. Labels test and label spread I have passed on. And now see this, guys. See this. So that is there, guys. Can you see this now? This is our confusion matrix, guys. This is our confusion matrix. Let me paste it here. See this, guys. Now, can you see this, guys? This is actually, you know, let me, if I, explain it, that out of total cases, how many total cases are there? Can we get a check? Yes, we can get. I need to calculate the length of the test cases. So how many test cases we had, guys? Features test ka length kitna tha? 93 total, you know, testing jo hui thi, that was done on the 93 records, guys. And out of 93 records, 53 cases kya hai? Where I predicted 1 and actually it was 1. 16 cases where I predicted 2 and actually it was 2. So 53 and 16 are the accurate cases, total, you know, correct cases. 8 is what? I predicted 2, but actually it was 1. 16 is what? I predicted 1, but actually it was 2. So that's how you read a confusion matrix. And basically confusion matrix is the way through which you can understand where your model is performing good or bad. Because to have a good model, what you need these two numbers to be high, right? Ye number, diagonal numbers zyada hone chahiye rather than these numbers. Guys, is that clear with everyone? Right? So that is the gear, guys, right? So and we can calculate the score as well, guys. Can we calculate the score? Yes, we can calculate the score. How to calculate the score? 53 plus, you know, 16 were the right cases, right? 69. So out of 93, right? Out of 93, guys. So that was coming out. So close to 53%, right? So ye hamar, is that 93, 53%, or am I wrong? Something wrong, or like, is it okay? 69 divided by 93%. Okay, the actual is 74%, guys. So that is there. So this is the way, guys, we, you know, use any classification algorithm and we perform a confusion matrix analysis in this, right? So that is there, guys. क्या ये चीज सबको समझ में आई? Guys, सबको ये समझ में आई, right? So that is there. Now, अब हम थोड़ा सा आगे चलते हैं और इस बार, this time, right, guys, so I'll like lucky एक और example लूँगा, and you know this confusion matrix, I will take one more example, and then you will get a more you know understanding about it. Don't worry about it. I'm going to take one more example for you, right? मैं एक और example लूँगा, तब और समझ में आ जाएगा if something is missing here, right? Now let's on, guys, to go and, you know, take one more example, and there we are going to apply a one more algorithm today, guys. एक और हम algorithm समझेंगे और उसको बात करेंगे. See this, guys. I have a new file for you today now, guys. And what is that file? Okay, this file is, okay. Guys, I'm closing this hard disease.csv and now see this. Kya hai ye? What the data is all about? The data file name is Caesarean.csv. So basically, again, data from healthcare industry. Basically, right? Now, guys, this data is about a the female that admit to the hospital when they have a labor pain and they admit for the delivery. So that is the data actually it is, right? And it is on talking about like that only, that when the lady was admitted, what was the age, right? What was the delivery number? Maybe it is talking about the kids. Delivery time, something is there. I'm yet to find out what exactly telling. What was the blood pressure, kind of that. Heart problem thi ya nahi thi, or was it a cesarean case or not? So guys, kya hai? The lady that got admitted was of 22 years old. That was the first delivery, right? I don't know about delivery time as of now. A blood pressure ka problem tha ya nahi tha, BP tha ya nahi tha, right? So that was there. Heart ka problem tha ya nahi tha, that was there. And finally, there is a column which indicates whether it was a cesarean case or whether it was a non-cesarean case, right, guys? So 0 indicates a non-cesarean case, and 1 indicates it's a cesarean case. So guys, what you say again? If we have a age, we have a delivery number, we have a delivery time, we have a blood pressure, we have a heart, a problem status, guys. After knowing these features, can we predict कि वो एक जो cesarean case होगा या non-cesarean case होगा? Can be predicted, guys, whether it would be a cesarean case or a non-cesarean case? What you say? Can be predicted? Yes, we can predict it. Or will it be a classification prediction, or will it be a regression problem? क्या बोलते हो? What is there, guys? Is it a classification problem, or will it be a regression problem? Obviously, it has to be a classification problem, Tejaswani, right? Why it has to be a classification? Because we are just predicting 2 classes. Either we are predicting 0 or either we are predicting 1, right? Because 0 means no cesarean, 1 means cesarean, right? So obviously it has to be a classification problem. It is not a regression problem, right? So that is there. Now, how to solve this problem? Okay, I can solve it using logistic regression, no problem around that, right? Right? And but for this time, I'm going to explain you one more algorithm, and the name of that algorithm is KNN. What is that, guys? KNN, K nearest neighbors. What is the name of that algorithm? K nearest neighbors. I will explain that part, right? But before that, हम लोगों को पहले first we should do the data pre-processing. First, we should do the data pre-processing part. So let's do the data pre-processing. How to do the data pre-processing part? That is very, very easy. We can copy from the upper, code now, and we'll change as per requirement. So we have so far, this is the case, guys. यहाँ तक हमारे पास है, right? So so guys, this is there. I copy it and paste it in here, guys. मैं यहाँ पे paste करता हूँ, right? And now you need to guide me what I need to do. So guys, as of now, I need to read the data first, right? So should I change the name of CSV file here? Yes, I need to change. So first, मैं यहाँ पे comment कर देता हूँ. I'm going to understand, we are going to use the KNN this time. That is there, guys. And pd.read CSV. And what is the name of that file, guys? Caesarean, right? So that is the case. Is that correct? Yeah, it is correct, guys. We get the data set here. So we got the data set. So data frame has been there, and now you can see, guys, we have a age, delivery number, delivery time, blood pressure, heart problem, and cesarean. So we got the data frame now. And guys, can we get the labels and can we get the labels, guys? What should I change here? Is it okay, or should I change something here that we can get a label? What you say, guys? I need to ask from you guys. क्या हमें यहाँ पे कोई change करना चाहिए like number 63 to get the labels? Actually, it is not required. Why? Because in this case also, our label is in the last column. And if it is in the last column, we can easily say -1 for that, right? So our labels are fine here. So we got the labels, guys. So labels are fine. Okay, I have another question for you guys. Can you suggest me that what range I should keep here, guys? क्या range मुझे रखना चाहिए यहाँ? बता सकते हैं? Can you tell me, guys, what range I should keep here? If you see this, guys, data frame बता देता हूँ मैं आपको. This is 0, this is 1, this is 2, this is 3, this is 4, right? So 4 तक include होना चाहिए, but we should go up to 5, right? So I think it should be from 0 to 5. So can we change it 9 to 5 कर देते हैं? Because 5 would be excluded, so it will be from 0, 1, 2, 3, and 4. So we get the features, guys, here. So features are also fine, right? Features are also fine here. So features are also known to us now. So features are known. Oh, what I made wrong? Okay, so features are okay, fine. So हमने यहाँ पे features को भी ले लिया है, guys. ठीक है? अब हमने क्या करना चाहिए? We should apply a train test split. So we do a train test split now, guys. So that's a train test split. Okay, guys. Let me know. Should we apply a feature scaling here or not? Can you what you say, guys? What you suggest? Should we go for a feature scaling, or is it okay we can bypass the feature scaling? I think it's a kind of, you can see the first column is in 2 digit and in rest of the columns are in just, 1 digit. So better to apply for feature scaling, but even if you skip it, it's okay, right? You can bypass. So the choice is with you guys, right? As of now, just 1 digit, 2 digit kind of comparison is there. So maybe you can pass, bypass that. But if you want to apply, you can, apply. There is no harm into doing that. The best practice is that you should apply. The best practice is that you should apply. So let's apply that part now, guys. So we are going to do the standard scaling. वो हमने apply कर ही दिया है. Class हमने बना ही दिया. So everything is same. We are not going to make any change here, guys. See this, right? So that's there. And now, guys, we need to, apply a different algorithm. So we are not going for a logistic regression as of now, guys. I'm going to apply a new algo, which is very, very, interesting. I will explain the mathematical aspect of it. So from sklearn.neighbors, right? So ये मुझे यहाँ पे neighbors import. Oh, sorry for that. Import k nearest neighbors. So k neighbors, guys. Neighbors classifier, it has to be. So from scikit-learn, I'm importing the k neighbors classifier. And let me explain you the mathematics behind it. It would be very, very interesting for you guys. So let me explain this with you. Okay, see this. Guys, see this. We have couple of people in a city, guys. We have a couple of people in a city. So let's say there are a couple of people in a city. Couple of people in a city. Okay. And for those people, we have their latitude and longitude with us. We have a latitude and we have a longitude with us. Okay. So what I can do, I can use x-axis to represent their latitude, and I can use a longitude on the y-axis, guys, right? So there is a one guy on this location, there is a one guy on this location. So rather than plus, I should use dot actually. So dot use करना चाहिए मुझे. Control chat. Okay. So guys, there, this is the one guy here, this is the one guy here, this is the guy, this is the guy, this is the guy, this is the guy. I say, you know, a couple of people are there distributed across the city. Okay. And now see this. This is just the location, guys. This is just their location, right? I can couple of add more here. And now, see this, guys. Every guy which we have a latitude and longitude, right, living in the city, we did a corona testing on them. We do a corona testing on them. So we find that this guy is positive, okay? This guy is positive, this guy is negative, this guy is negative, this guy is positive, this guy is negative, this guy is positively tested, this is negatively tested, this is negatively tested, this is positive tested. Let's say this is also positive tested, this is negative tested, and this is negative tested. So guys, do you understand this visualization that what I'm talking about? Is that clear with you? Right, so there is a lat long. Let's say everybody has a Arogya Setu app, and that Arogya Setu app has a lat long with it, and you know we can easily figure out, you know, in terms of you know that distribution in a city. Okay. Now, okay, so Akshat, it is just like, you know, बहुत सारे लोग हैं सिटी में, और हर बंदे का lat long हमें मालूम है कि वो कहाँ रहता है, right? And we are just showing that data. So we are taking the latitude on the x-axis, right? Because if you know from the Google map, right, every location is marked through lat and long, right? Lat long से पता चलता है कि किसकी map पे क्या location है. So that is the x-axis we have, and this is the y-axis we have, guys, right? And ये एक बंदा है जिसका latitude ये है, longitude ये है. ये दूसरा बंदा है जिसका latitude ये है, longitude ये है. ये तीसरा बंदा है जिसका latitude ये है, longitude. So these are the kind of a coordinates in terms of a trigonometric visualization, right? So these are the kind. Okay, now guys, let me ask you a question, right? Let me ask you a question. Now there are two people, right? एक बंदा है वो यहाँ है. That is the location of that guy, right? And guys, there is one more guy who is, let's say, where I should place it actually. Okay, I can place it here, guys. That is the second guy we have. Okay, so ये तो एक बंदा है, and this is the second candidate we have. Okay. Now, guys, can you give me a prediction for this candidate? Will it be a positive corona or will it be a negative? And what about this candidate second as well? So first I'm talking about this candidate, guys, right? Will it be a negative or will it be a positive, guys? What you say? What should be our prediction? Whether it would be a negative or whether it would be a positive one? क्या बोलते हो? So a lot of people are saying negative to us. Okay, now give me the logic that why it is a negative. Why it is negative. Can you give me a logic for me? Okay, so now this reason is very simple, guys. Reason is very simple here, right? Because this guy is living in the community, right? And we all know, you know, because Corona is, you know, a kind of a pandemic, which is, you know, very much related to the, you know, kind of vicinity. So see this, guys. Let me take that, you know, we take we consider that what are the three nearest people living to this guy, right? Who are the three nearest living people? So this is the living guy, this is one more living guy, and this is the one more living guy, right? And now guys, you can see that, you know, two people are negative and one guy is a positive around him, right? So is bande ke aas-paas, that is the vicinity we are talking about. इस बंदे के आसपास नियरेस्ट तीन लोगों का कलेक्शन हम देख रहे हैं. Two people are negative and one guy is positive. So our prediction will go with majority, right? So we will predict this as a negative candidate. What about this guy, guys? Can we see? Okay, if we look at the three nearest people living to this guy, so this is the nearest guy, this is the nearest guy, and this is the nearest guy, right? And now here you see this is a positive guy, this is positive guy, and this is negative guy. So here the majority is positive. So our prediction for this guy would be positive, right? So basically based on the distance, right? Based on the distance, we are calculating, we are making a prediction about the corona, right? The similar concept works with K and N. Similar concept works with K and N. That is K nearest, you know, neighbors, guys. Based, so iska matlab KNN is a distance based algorithm. It calculates the nearby people, right? Nearby logon ka distance pata karta hai, right? And generally, guys, we consider the odd number of people in the vicinity. हम generally positive, you know, or odd number ही लेंगे. Why to take the odd number? So that we do not have any issue with the tie. Tie नहीं होगा. Otherwise मैं अगर चार nearest लेने लग गया, दो positive हो गया और दो negative, तो मैं decision नहीं ले पाऊंगा. That's why we keep this number as odd. So the K जो है ना, K, generally the default value of K is 5. Generally the default value of K is 5. So generally the default value of K is 5, right? So you know, K can be 3, K can be 5, but the default value is 5. So we look out the 5 nearest people, 5 nearest points, right, on the coordinate system, and then we take the decision. Guys, is the basic logic behind the KNN clear to you? I will explain a couple of more things in the KNN now. Okay, and now point comes, because we all, most of us are like, you know, most of us are like, you know, from the mathematics background. Maybe a couple of people maybe from the non, you know, that. So see this. If you remember from the trigonometric days, guys, right? If you remember, trigonometric days, guys, how you see, let's say there are the 2 points on our coordinate system. That is point P1 and this is point P2, right? This is x-axis, guys, and this is y-axis. Okay, the point P1 is represented like x1 and y1, and this is represented as x2 and y2. Okay, and now we need to find out a distance between these 2 points. हम इन 2 points के बीच में distance पता कैसे करते हैं, guys? Do you remember the formula which we used to have in 12th or like, you know, engineering mathematics? The distance between P1 and P2 it calculated like this: x2 minus x1 k square plus y2 minus y1 k square, and then the square root of this, right? Guys, do you remember this distance D is called as Euclidean distance, right? Euclidean distance, guys, right? So that is called as Euclidean. So KNN, you know, uses this formula, right, to calculate the distance between the nearby points. Okay, one more thing, guys. हमने mathematics में ज़्यादातर cases में यही distance पढ़ी है, but there are a lot of other distances as well as, guys, right? You know, that will give us, kind of one more distance. I'm going to explain one more distance to you guys. See this. Rather than going this direct way, it's a kind of an aerial distance, if you remember, right? Can we go horizontally first? So I go horizontally. And if I go horizontally, basically what is the distance covered? X2 minus X1. Okay. And then I go vertical. So then that distance would be Y2 minus Y1. Or maybe I can go vertically first. That would be Y2 minus Y1. And then go horizontally. That would be X2 minus X1. Right? So there is one more distance which can be there, and that is X2 minus X1 ka absolute plus Y2 minus Y1 ka absolute. Absolute matlab positive magnitude part only. Or okay, maybe we can do one more game. हम थोड़ा ऐसे चलते हैं इधर, फिर थोड़ा वर्टिकल, फिर थोड़ा हॉरिजॉन्टल, फिर थोड़ा वर्टिकल, फिर हॉरिजॉन्टल, फिर वर्टिकल, हॉरिजॉन्टल, फिर वर्टिकल, ऐसे ऐसे करके भी जा सकते हैं. बट दैट डजंट मैटर. Overall distance would always be this only, because you are just moving, delta x and then delta x, then delta x, then delta x, then delta x, and delta x, and delta x, that will always equal to x2 minus x1. Similarly, delta y, delta y, delta y, delta y, delta y, delta y, right? Similarly, y2 minus. This kind of a distance, which is more real in terms of a road transport or something like that, this distance is called as Manhattan distance, guys. इसको हम लोग trigonometry में या mathematics में Manhattan distance कहते हैं. Why the Manhattan? There is a center part of the New York, right? New York में एक हिस्सा है Manhattan actually, right? Where every road crosses at the 90-degree actually. And that's why the distance name came from that. So Manhattan distance is there. So guys, do you understand that, in applying the KNN, guys, in applying the KNN, we can use either, the Euclidean distance, or we can use the Manhattan distance as well. मैं बता सकता हूँ. I can specify while calling the KNN algorithm that which distance you need to use for calculation, right? And how many nearest point you have to look at to get a prediction, right? How many nearest point you have to look at. So let's go to the code again and, solve that problem and close it, guys. So now, guys, I need to create a classifier first. So मैंने इस algo का constructor call किया. We created a constructor here, guys, and what is that? उसका नाम क्या रखें हम, guys? What should we do that? Classifier. Okay, so we are going to keep it classifier, right? See this classifier. Okay. And now, guys, while calling the constructor, I need to specify two parameters here. Kya parameters hai, guys? Right? What are the parameters that I need to pass on? I need to pass on two parameters. So comma लगाया, एक parameter comma के पहले दूंगा, एक parameter comma के बाद दूंगा. First, I'm going to talk about the second parameter. The second parameter is P, where P actually specifies that which distance you want to apply, guys, right? So if you say P is equal to 2, it is going to consider the Euclidean distance, right? And if you say P is equal to 1, it will consider the Manhattan distance. So guys, is that parameter clear to you? That if you pass on the P is equal to 2, it is Euclidean distance. If you pass on P is equal to 1, it is a Manhattan distance, right? And if you don't pass on this parameter, अगर आप ये parameter नहीं देते हैं, it takes Euclidean distance as default, right? If you don't pass on the data. Okay. And then what about the K? The K is specified here as neighbors, n underscore neighbors, right? So n underscore neighbors. By default, it is 5, but you can pass on some odd value here, right? So now see this, guys. This is the way I'm going to call it. Classifier. दो parameter pass कर दिए हैं. Neighbors is equal to 5 and P is equal to 2. That means it is going to consider the Euclidean distance, and it is going to consider the nearest 5 points around it while making the predictions. So that makes our classifier ready for the training. अब हम इसकी training कर देते हैं. So how to do the training? So we are going to train the model this way, guys. And now we are going to finally perform the prediction. So here we have the prediction. And now we can easily compare that what the confusion matrix is coming. So let's copy the confusion matrix part from the earlier code section. So here we have this confusion matrix already with us, guys. And here we see it. So now let's print it, guys, confusion matrix. So see this, guys. This is, see this. Yeah. How many classes we had, guys, in this? 0 or 1. दो ही classes थी, right? So what is the meaning here of this? The meaning of this confusion matrix is this, that model predicted 0 and actually it was 0. There are total 7 cases like this. Model predicted 1 and actually it was 1. 4 cases are like this. Model predicted 1 but actually it was 0. 1 case only. Model predicted 0 but actually it was 1. 4 cases like this, guys, right? So समझ में आया 0 का मतलब नॉन सिजेरियन, 1 का मतलब सिजेरियन. वही चीज हमें यहाँ पे कंफ्यूजन मैट्रिक्स में देखने को मिल रही है. तो कितने करेक्ट केसेस हैं हमारे केस में, गाइस? This is the correct case and this is the correct case. So 7 plus 4, 11 are the total correct cases, right? And 16 are the total cases. तो wrong कितने हुए? 5 cases गलत हैं और 11 cases सही हैं. So this is the way, guys, you perform, right? You can put around that. See this, guys. Okay, maybe we can change with some values. So let's say I put it 11 here, right? Or maybe I put it 1 here. So I want to, I'm just changing the parameters. Does it change my, a prediction anyhow? Possible है कि prediction में changes हो जाएं. That may be possible that, it may change your, predictions here. And see this, guys, this time we have different predictions. So if you change the parameters, obviously you have the, the different results with you. So guys, so guys, this is, अब कौन सा better होगा, whether it's a Manhattan or whether it's a Euclidean or whether it's a k is equal to 5 is better or 11, it depends on the results. First you have to look at the results and then only you can take a decision that which one is better, right? Beforehand you can't make a a decision that which one is better, right? So that is there. So नितेश 5 और 11 मतलब आसपास के कितने लोगों का चेक कर रहे हैं हम लोग? जैसे हम लोग उस पर्टिकुलर एग्जांपल में चेक कर रहे थे ना, 3 लोगों को, नियरेस्ट 3 लोगों को चेक करना है, इफ यू रिमेंबर फ्रॉम द प्रीवियस स्लाइड, राइट? तो यहाँ पे वो 5 है, राइट? वो 5 लिया है हमने. इज दैट क्लियर, नितेश? राइट? सो दैट्स देयर. सो गाइस, आज की कहानी कैसी रही? हाउ वाज द स्टोरी फॉर टुडे? Akshat saying, sir, today's webinar was 100 on 100. Yes. Venkatesh saying, sir, it was super. Paridi saying, interesting. Purvi saying, nice. Sumit Devedi saying, good. Swati Lohia saying, interesting. Okay, Deepak Warre saying, mixed up. Teja saying, Fosk, sir, is best. Alampalli Manisha is saying, very interesting. मोहित जिंदल, एक बार वीडियो देख लेना, समझ में आ जाएगा. ब्रेक लेने के बाद देखोगे ना मोहित, तो समझ में आ जाएगा, डोंट वरी. प्रियंका गुप्ता saying a very nice session, sir. Shubpreet Kaur saying very good. Bhaskaran Venkat Raman saying good. Nitesh saying sir, superb. Deepika saying interesting. Manisha Das saying sir, it was awesome. Okay, Chandra, computer science and engineering, 10 on 10. Avinash Reddy saying, sir, 1000 on 1000, right? Sahil Rahman, जिसका confusion matrix अच्छा हो, वो algorithm choose कर लो, right? So, that is the case, guys, there. That is the case. So, this is there, guys, right? निधि, दोबारा आप देखोगे तो आपको समझ में आ जाएगा. अमर यादव सिंह सर, मजा आ गया. अनिल सिंह, गुड सर. Lipika ma'am saying, sir, last time I missed this class, but this time it was good. Avinash Reddy saying, sir, you are the best teacher for me. Pratpal Kaur saying, sir, interesting, but second algorithm में थोड़ा issue है. Okay, don't worry. दोबारा देख लेना प्रीतपाल जी, वापस समझ में आ जाएगा. Don't worry. It's a very nice. Jaya Sharma saying good explanation, right? मोहित जिंदल कह रहे हैं कि सर आप बताइए कि रिज्यूम कैसे बनाएं. ओके. प्रणव राणा सिंह सर प्राउड ऑफ यू. ओके. Ninja, you need to increase the training data, or maybe you change the algorithm. You may use other algorithm than linear regression. Tejashwini saying excellent. Okay. We have a session tomorrow, guys. We have the last session tomorrow. Okay. And that is there, guys. दीक्षा confusion matrix में simply ये बताया जा रहा है क्योंकि हमें सिर्फ 2 ही classes predict करनी थी, 0 या 1. 0 था नॉन सिजेरियन, 1 था सिजेरियन. तो 5 तो represent ये कर रहा है कि मैंने predict किया 0 और actually भी 0 था. 6 वो represent कर रहा है कि मैंने 1 predict किया और actual में भी 1 था. 3 represent कर रहा है कि मेरा prediction 1 था लेकिन actual 0 था. 2 ये represent कर रहा है कि prediction 0 था लेकिन actual में 1 था. Right? That was there. Diksha, right? So that is there. Sudhanshu Lenka saying, sir, excellent, right? Shakuntala saying, sir, thoda confusion hua hai mujhe. Okay. Vipul Gohil sir saying, sir, this is the 5th course I'm doing and it's always superb, right? So that's there. Sahil, what you say is basically called as label encoding, right? So label encoding के केस में वो priorities मानने लग जाता है कि 1 has a higher priority and the 2 has a lower priority and so on. So we don't go for that and we go for one-hot encoding, right? So that is the case. So that's there. So guys, we have the last day tomorrow, right? MATLAB is a different tool, guys. Avinash Reddy is saying, sir, difference क्या है MATLAB में और Matplotlib में? वो अलग tool है. Matplotlib visualization की library है. MATLAB में बहुत सारी चीजें अलग होती हैं, right? Yeah. So that's the case, guys, here, right? So that's there, guys. Yeah, Naman, दोबारा पढ़ोगे तो समझ में आएगा, right? Sahil, I answered your query, right? Generally, Bhaskaran, it is not possible what you are talking about. Maybe you can drop or add, new columns and all that, right? So that's there, right? कल हम लोग क्लासिफिकेशन की फिर से 2 नई एल्गोरिथम्स को देखेंगे, राइट? रजत जालंधर, उसका सॉल्यूशन गूगल ड्राइव पे अपलोड कर दिया गया है, राइट? Venkatesh, as of now, we focus on the practical part of the machine learning rather than on the research side, right? So that would be the case, guys. This code would be shared with you soon, guys, right? And
it's already shared on the drive.
Okay, guys. Okay, guys, register. Okay, so there is a one more announcement coming for today, guys. Book your certificate there on the given link, guys. Book your certificate. And I was just, looking at the data, the sheet, guys. I was just looking at the sheet. I think a lot of people have already filled the form. They have, I think more than 20 people have already gone for the certificates even during the class period, So that's there. I can name a couple of them, Mala, Joy, Sumit, Deepak, Sahil, Sonu, a lot of people are there in the list. So they have applied, this guys. I will cover SVM and Navies tomorrow, right? So that is there. So Naman, I think that was an extra code. We did not cover about it, but the OLS is like linear regression, right? So optimal least square, Naman, optimal least square, it's a regression only, but we use a different library. That library is stats model, right? That library is a stats model. But again, that is linear regression only. Yeah, man, you can do that. आप एक individual value के लिए, individual value के लिए भी आप prediction perform कर सकते हो. That is possible. Very well possible, right? कि हमारे यहाँ पे see this समय, let's say we have these values, right? So we have this value in the x. यहाँ पे एक list बना लेते हैं. See this in the list, right? This is x. So इस data पे मुझे prediction निकालना है हमें, right? So पहले क्या करना पड़ेगा? X is equal to np dot array. क्या पास किया? X पास किया, right? And now what you see, a classifier dot predict, right? And what you can pass on the x. But x के लिए तो मैं यहाँ पे दो चीज़ों का ध्यान रखना पड़ेगा. तुमने क्योंकि यहाँ पे स्टैंडर्ड स्केलिंग अप्लाई किया था, so you will have to apply the standard scaling as well, right? तो मैं स्टैंडर्ड स्केलिंग भी अप्लाई करना पड़ेगा. Then only you can do that, right? So x is equal to what you do that? sc dot transform, right? यहाँ पे किया और x किया. So that is there, right? So that's there, and okay, it is saying that it has to be in a 2D array. So x dot andim देख लेते हैं क्या है. X dot shape क्या है देखें जरा. So x dot shape is there 5. So we need to have a 5,1 actually, right? So x is equal to x dot reshape 5,1. So that is there. और अब निकालो जरा इसका prediction, right? So what is that? 5 होना चाहिए, 4 होना चाहिए था. Let me check this part, guys. Caesarean, so 1, 2, 3, 4 और 5. What is that? See this. Okay, let me check with that. Features strain dot shape क्या था? Oh, it has to be 1,5. Okay, so 1,5. ठीक है. So ये हुआ हमारे पास 1,5 and हमने इसको निकाला. So now you can see हमें we got the prediction as 1. ठीक है. So that is there. Okay, Vipul sir, thank you. So guys, is that clear with everyone? Is that clear? मशीन लर्निंग से अब तो डर कम हुआ कुछ. ये तो नहीं कहेंगे कि आप लोग एकदम एक्सपर्ट बन गए हो, बट आई थिंक यू शुड हैव अ कॉन्फिडेंस नाउ, राइट? Akshat, please write an email to fastlabs@gmail.com if you have any issue with your previous certificate, right? Please write the email onto that. So गाइस कोई कुछ शेयर करना चाहेगा आज के फीडबैक में? आज कुछ लोग कहना कुछ चाहोगे? Would you like to share something? Vansi, are you there? Did you get it today? Diksha saying, sir, I understood more than the paid internship. Thank you, Diksha. Very good. What is your college, Diksha? Which college you belong to? Which city you come from? Mm. Amar Jadhav saying, sir, I enjoyed a lot. Okay, Diksha is from NMAM. I'm not sure about NMAM, Diksha. Rajat saying it was very good. Okay. शिवानी गहलोत हैं यूसीईटी बीकानेर से. अच्छा, बीकानेर से हैं. सर आपका लर्निंग प्रोसेस इज़ वेरी क्रिएटिव. थैंक यू शिवानी. आई थिंक वहाँ पे नीरज मैम हैं. नीरज मैम मेरी एक बार कोलीग रही हैं. आई नो दैम पर्सनली. नीरज चौधरी, नो शिवानी. सो इफ़ यू आर फ्रॉम दैट कॉलेज. संजय बंसल जी जहाँ पे अभी प्रिंसिपल हैं. संजय बंसल जी मेरे एक बार टीचर रहे थे when he was in my college as a faculty. So okay guys, yeah. Registrations are coming now, guys. People have started applying for the certificate now. Last time, if I remember the data, out of 500 people that the program that we did was on Python. I think out of 500 people, 400 people went for the certificate. 400 लोगों ने certificate लिया था out of 500. और हमें close करना पड़ा था. Actually, हमने मना कर दिया था कि भाई हो गया पूरा. So that is there, guys. Can we close it for today now, guys? Can we close it? Naman Chaturvedi saying, sir, is there any of your center in the Jaipur? हाँ भैया, जयपुर ही हमारा head office है. We have office over in Sitapura. Sitapura industrial area में ही हमारा certificate है. वो है office, Sitapura Startup Oasis, right? That is there. And the interesting part is this, guys. Today we were covered by Your Story as well, right? Your Story is one of the largest, digital platform for startups in India. आज ही Your Story में हम लोगों को cover किया गया था. So guys, if you want to see, this is me. This is basically the image from the winters, and this is Sylvester, and this is our one of the advisor, Karthik. He's working in Canada. He's working in a very big bank there, and he's leading the AI team, entire AI team there. Karthik Mathur is there. So we were covered by Your Story as well. So guys, Nikhil Mathur has recently went for certificate. Botu has registered for certificate just now. I'm just getting the notification, So guys, I would request everyone to go for a review us, please, yeah, Paridhi, we do that. Please contact on the given email, right? आप email पे एक बार contact करें. So college कौन सा आपका परिधि? So guys, okay, you are from Manipal, okay. Manipal, okay. कौन सा branch है Manipal में परिधि? CSE. Okay. Who is the professor? Who is the HOD there right now? Is Mr. Dhaka or कौन है वहाँ पर अभी? So OCC में, yes, I understand that. I know a couple of them. I think earlier it was, who was there? I think Mr. Kolhari was there. Okay, we have Sandeep right now. Okay, I got it. ठीक है. We used to know your former VC, Sanchiti. Professor Sanchiti was very close to us. And Dr. Sylvester have met Mr. Prabhu a couple of times in a couple of board meetings earlier as well. I know Dr. Razveer Shekhawat personally. He's a very good man, very nice person. He's a director, I think, there right now in your school. So so that's there, guys. So please write us a review, guys. परिधि ने कल बहुत ही अच्छा review लिखा था Google के ऊपर. Thank you, परिधि. It was very well, written. Thanks for that. So, guys, tomorrow we have the last what you will say, last session for the current program, and we have a new program coming up from next week. That is AI and ML with Python, right? AI ML. So we'll cover the deep learning part in that session. The next week जो session आ रहा है उसमें deep learning भी cover होगा. एक दिन deep learning के लिए भी दिया जा रहा है उसमें, that is there. So thank you guys and bye bye. See you tomorrow at 4 p.m.